Thanks for joining us tonight in person and online to discuss found designing for the reuse economy. I'd like to start with an acknowledgement of country, acknowledging the Wadawurrung people from whose land we speak tonight, acknowledging their ownership. I'd also like to pay my respects to the elders, past and present. Over the next hour, we're going to run through a bit of background on what our waste situation currently is, then discuss what challenges and opportunities there are for reuse in the Australian economy and how we can better support the reuse industry to grow. If you have any questions along the way, feel free to shout out, or if you're online, pop them up in the chat box and I'll do my best to respond. So, kicking off, a bit of background. At the moment, every Australian, every year, throws out about 24 kilos of wooden furniture. And you might be saying, I would never do that, but if you start to think about it, 24 kilos is one dining table or one TV unit, and for a lot of people, it wouldn't be that unusual to replace one large item of furniture every year or so. I think the more interesting stat is actually out of Germany. It's that only 8.3% of appliances that are purchased new in Germany are purchased to replace defective ones. Now, that means that over 90% of all appliances sold in Germany are purchased for other reasons. So they're either purchased because the individual doesn't have an appliance to do that job, or they're purchased to replace perfectly good things because they're a better color, they're a newer model, they're a shinier version. That means there's a heck of a lot of perfectly good items that are being thrown away and replaced for no functional reason. Also a bit staggering is that charities in Australia, so op shops, spend $13 million disposing of unwanted donations every year. And that definitely includes the donations that are illegally dumped out the front of their op shops or out the front of their donation bins, but it also includes a lot of potentially perfectly good or usable items that are simply items they can't utilize in their particular op shop because they don't meet the needs or expectations of their customers. Just to give a sense of the scale of the industry and impact of reuse in Australia at the moment. In the case of op shops alone, there's about 2,500 op shops in Australia, and that's getting up towards the same number as the number of supermarkets across the country. And that's a small part of the reuse economy, so that's not taking into consideration all the tens of thousands of pawnbrokers, micro businesses, vintage markets, antique shops. As far as the impact they have, op shops alone save more than 500,000 tons of materials from landfill every year, and by comparison, the entire recycling industry in Australia only recycled 320,000 tons of plastics in the 2017-18 financial year. So I can say just with the stats from op shops alone, there is a big impact on the amount of waste that we generate in Australia from the reuse economy already. Now, my background's in design and engineering. I just wanted to introduce all of you to a little bit of the basics of what goes into making a product, whether that's a product from new materials or used materials, to give you a bit of a feel for where some of the benefits and risks are in different manufacturing types. And when you're making a new product, really materials, machinery, and labor are three of the biggest cost components. So materials being whatever it is that you're using to make the product out of, machinery being the equipment that you use to make either the individual parts or to assemble those parts into a finished product, and labor, of course, being the human element that's involved. So as far as materials are concerned, if you're making a new product, generally the raw materials you're using will probably be about the same raw materials no matter where in the world you're making the item. You'll be purchasing quality assured plastics or metals from one of maybe half a dozen suppliers in the field of that particular material, and you'll be purchasing from the same supplier whether you're making it in Australia, China, or Canada. It'll be the same material, the same maker, and therefore the cost will be fairly universal of that material. Quality componentry is the same, so My Samsung phone's got a microprocessor made by the same company that makes the microprocessors in probably half a dozen other brands of phone. Pretty much every laptop or desktop PC that's available now has processors and RAM made by maybe 3 or 4 different companies. So again, the cost of those component level elements is pretty much the same wherever you're making the product. Now, when you start to get into reused and recycled materials tend to be a little more expensive than new materials, and a lot of that comes down to efficiency. So, if you're using a new material, you're digging it out of the ground or growing it on a tree. You've got a consistent location that you're bringing it from. Where recycled materials, you've got to collect the raw materials from a much bigger area. It's a more labor-intensive process, and by the time you've sorted it and cleaned it and prepared it, more often than not, unfortunately, at the moment, it's costing you more to make a recycled material than it is to make a raw material. When it comes to reuse, you're taking things a step further because to get a consistent material, you need to have a consistent object, not just a consistent material that it's made for. That means you need to potentially sort through a heck of a lot more objects to get a level of consistency, and those sorts of volumes aren't really available to the reuse industry at the moment. Now, machinery is very much the same case as materials. So, if I'm manufacturing a new product in Australia, let's say an injection molded plastic part, the machine I'm using here is probably pretty similar to the machine that I'm using in China or England or anywhere else in the world. Within that machine, I'll have some custom made tool parts that make that machine produce the product that I want, and those parts I could get made in Australia at a higher precision and a higher cost, but I could also a lot of the time get those tool parts made in China by the exact same people who'd make them for the Chinese manufacturers and get them sent over here at a cost comparable to utilizing them over there. Now, when it comes to new versus reused, again, the recycling industry, because recycling is breaking things down into smaller materials, there can be a degree of automation machinery involved. And when there is, that machinery might be doing simple things like crushing bricks and crushing old masonry down into smaller elements that we use for road surface, or grinding glass back into sand. And in those sorts of volume operations, there is automation machinery out there that can make materials reasonably viable for use. But because we've got the materials consistency issues or challenges that we have when working with reused items, so when we're working with the whole item rather than its broken down materials and components, there's not really a lot of automation machinery out there that's set up to deal with that. You need much more complex machinery to deal with notable variations from one part to the next, rather than dealing with a nice consistent universal feedstock. And therefore there's not a lot out there, and what is out there is quite expensive. Labor is really where the big impact is in both of these comparisons. So you can see the average factory labor in Australia is earning about $26 an hour. The average factory labor in China is earning about $4.50 an hour. And I've had this experience firsthand. I've designed and developed products and cost compared to making them in Australia versus overseas. And generally speaking, if they're a product that can be made in a completely automated fashion, because as I mentioned before, the machinery and the materials costs don't differ greatly, I can make these products in Australia for, when I'm talking new products, for basically the same price that I can make them in China or in India or in any of the countries that are often used for cheap products. Where the variation comes in, though, is if manual inputs involved. So if I need that product to be assembled by hand, or I need it to be packed by hand into a box, all of a sudden it's just not cost comparable to produce over here. Now, in reuse, because we don't have the consistent materials and therefore we don't have the machinery available to automate reuse, reuse is always going to be a more expensive proposition, because it's going to be more labor intensive. And you'll see, I know I get in my Facebook feed a lot of videos of people in the developing world recycling car or repairing and reusing car batteries or car alternators or doing really heavy vehicle repairs and reconstructions. And in countries where the labour rate's $4 an hour, our H&S issues aside, you can repair some of those products. But in Australia, that $26 an hour that you're paying the average factory worker, that's probably costing the company, by the time they've included all their overheads, about $100 an hour. And you can quickly see how doing repair work and repurposing work can add up in a great rush and make it very hard to compete a lot of reused products against new ones for that reason. So making reuse cost effective. So to make reuse more viable in first world economies, we need to reduce labour. To reduce labour, we need to be able to increase automation, and to be able to be able to increase automation, we need consistent feedstock. So we need accessible, quality, uniform materials. So how do we add this consistency? Getting consistent materials. If I'm making a new product, when I'm working with virgin materials, then I'm digging those materials out of the ground. I'm growing them on a tree, I'm growing them in a field. So I'm collecting them from a single source. I'm then breaking them down into tiny little elements so they're really nice and consistent and easily sorted into a feedstock that changes very little over tens of thousands of kilos of material. Now, if I'm working with a recycled material, as I said before, it takes a little bit more labor to collect and sort and clean materials, but I can take materials from potentially a whole lot of different products that happen to be made out of the same material, and then I can break them down in the same way that I break down a new material, break them down until they're a tiny little building block that can be sorted, refined, and used as a highly consistent feed material again. But when I'm working with reuse, I don't want to break that object down. And because I don't want to break that object down, the only way I get consistency is by having identical objects or near identical objects. And that means I need to deal with a lot more objects in order to be able to filter and sort them into consistency. So I touched on the scale of the reuse industry before, and scale really becomes a big part of what makes reuse viable. So Savers is a really good example of how reuse can be economically viable at the right scale. Now, around the world, Savers stores, there's 300 of them now. They've got 22,000 staff and save about 300,000 tons a year of waste. And they do all that while operating as a for-profit and giving money back to charity. That the models and the principles they've used have managed to not only pay wages and not only allow them to be successful, but they've caused challenges when they've landed in Australia for traditional op shops by working so well in the model that they've got that they've drawn customers away from traditional charity op shops. Now, while that works for Savers, a huge amount of the reuse industry that we've got in Australia at the moment is micro businesses or sole traders. So they just don't have a method of utilising some of those big business economies of scale efficiencies that the competition can. Because as reusers we can't break objects down and define materials. We need consistent objects, and we need a lot of objects. And for micro businesses, that's just not viable. But perhaps there's a way that we can work together to make economies of scale work while still operating our own small businesses. Interesting aside, many people think that the large manufacturers and traditional businesses are against reuse and against the circular economy and against some of these principles because of the mindset of products having a set life expectancy and being able to sell a new product every however many years, but that's not always the case. So Xerox has been running product as a service for decades as part of their commercial photocopier line. So they rent out photocopiers basically on a page or on a monthly rate, and by doing that, they have an incentive to make reliable photocopiers. So their photocopiers are designed to last years and years and years, and they're designed so that when a component wears out or has a fault, it's really easy to swap. It's a modular part that the person who's operating it can replace themselves. It can self-diagnose in some cases what its fault is, and it can order parts. And there's also levels of interchangeability. So unlike your home printers, a Xerox copier from 10 to 15 years ago might share a lot of its components with a brand new one that's available today, and that way they have regular parts supply. They don't have to keep huge stock of variations because it's in their best interests to simplify and make things consistent. And while we don't see a lot of it in other parts of the market, it's definitely something that can be done. Now look at large appliances, washing machines, hot water services. Those same models could be applied. Your washing machine drum doesn't generally wear out, and neither does the outer case that your washing machine's in. So in theory, there's no reason why a washing machine motor, for example, couldn't be a quick modular interchangeable part, or a washing machine control panel couldn't be something that you could clip in and out yourself and have replacement posted out to you. Hardwood furniture is another example. So while a lot of the furniture we have in Australia is imported, we still have a reasonable amount of hardwood furniture made here. And in part, that's because fully assembled furniture takes a lot to ship, and therefore we can cost comparably manufacture it here. And especially for hardwoods, if we can make disassembly easily enough, it's certainly going to be more cost effective to strip and refinish a perfectly good table than it is to make one from scratch. So hardwood furniture is a viable product for reuse or for product as a service models. Couches are the same if we can get the labor content right. So at the moment, replacing upholstery on a couch is generally an incredibly expensive process and costs you more than buying a quality new couch to reupholster your old one, because of the labor that's involved in making a pattern for the fabric, pulling the old fabric off, repadding the frame. But if brands are willing to make a universal frame, someone like Tessa, who was in the Australian market for the better part of 50 years, they had some couch and chair designs that ran for almost that entire 50 years. So in theory, they could have offered replacement cushions for their chairs as aftermarket options to refresh their product. And couches for other makers are the same in theory. If you make the upholstery easy enough to remove, there's no reason that it can't be removed and replaced, and the frame and structure of the couch can't be used on and on and on. Let's talk a little bit about automation and reuse. I'm going to use the example of jewelry made from old spoons and forks and cutlery in general. Now, if let's say I make necklaces from the handles of old cutlery, the necklace the handle needs to be modified to attach the chains. It needs to be bent and have a little hook in it, and it needs to be aesthetically pleasing. So it needs to be well proportioned. So if I'm making, say, 5 or 10 pieces at a time, I probably hand pick a collection of spoon handles that I like. I mark the point I think they should be bent at. I then cut every one of them individually, bend them one at a time, possibly in a vise or some hand tool, and then I grind and polish the end that I've cut and give the whole piece a final polish. And that's labor intensive, but it's doable. Now, if I want to do, say, 50 pieces at a time, all of a sudden that process of marking every single one of them becomes quite a lot of labor content. So perhaps of those 50, maybe I'll do 10 handles that are from a matching set of cutlery. And that way I can mark the first one, I can set a little jig up, and I can repeat my cutting and bending process really quite quickly for all of the identical ones. Well, let's say I start to try and make 500 at a time. Perhaps if I'm making 500 at a time, I can afford some sort of cutting device that allows me to cut a number of handles at a time, or that allows me to semi-automate the folding and the polishing processes. Maybe I can also buy a small tumbling polisher, which so tumbling polishers are something that's used in conventional manufacturing, in new product manufacturing. Parts get dropped into basically a bucket of aggregate or beads, and they get shaken around within that aggregate until all their sharp edges are scrubbed off. Potentially, I could use a device like that when I'm producing 500 pieces at a time. Now, if I want to produce 5,000 pieces at a time, I've really got to look at automating the whole process. And since we're really just talking about cutting, bending, polishing, there's no reason that can't be done. They're relatively simple processes, but I would need to have a method of programming my equipment to be able to understand the differences between one set of handles and the next set of handles, so that it understood where to bend and where to cut each slightly different style of spoon. Now, obviously, the jump from 50 to 5,000 pieces at a time doesn't come overnight. And because of that, investing in the automation equipment that will be beneficial to you when you hit 50 or 500 units or 5,000 units might be really hard to do when you're producing tenfold less than that. Knowing when you're going to get that return on your investment, and if you ever are, and whether there's enough demand, that becomes a big risk for a small maker. But the other big risk that comes up is material supply. So if I'm making 10 pieces or 20 pieces a day, it's not that hard for me to go out to local op shops and trawl through their cutlery drawers and pick out pieces that I like. But if I'm making 500 pieces at a time or 5,000 pieces at a time, the time that it will take me to source that many pieces of cutlery individually is just colossal, and there needs to be a more convenient, more efficient way of gathering those raw materials. Now, that efficiency and managing to make it through those different levels really comes back, I think, to finding ways to work together. So being able to share equipment between different makers until those makers are at a level they can purchase that equipment themselves. Being able to share a network of knowledge of retailers, of skills, being able to share a materials resource, so materials that one maker may not need but may have access to, and another maker may need but not have access to. Having a network and working together is also really going to help us to better understand and better put a number on the environmental impact that we're having. And because we'll be able to put that better number on, we're also going to be able to gain greater awareness of what it is that we're doing for the environment, and what it is we're doing to reduce landfill, and the benefits of the reuse economy that are, much harder to see when everybody's working separately. So, what might centralizing reuse look like? What if we could have multiple businesses using the same automation equipment? What if we could pool all our materials in the one location and sort them and optimize them for all the different makers who could utilize them? What if that location became a hub for salvageable materials, a place that not only gathered materials, but that people knew to come to deliver materials to? Now, mismatched cutlery and pieces are thrown out every day. If you don't have a perfect set, you don't have value for it. You buy a new set, you're probably going to throw out what you had before. Yet there's makers all over the country trawling op shops and paying money for lonely pieces of cutlery to reimagine. Old blankets are the same. They get used as dust covers on machinery, as dog beds. I've been given beautiful old blankets to use to pad and protect items that I'm transporting for people. Yet makers such as the people who make the dog coats and dresses and little kids coats in our shop, they hunt high and low for good quality blankets and pay good money for them in the right colors. So we really need to find ways to connect the waste streams that are out there to the makers. We need to make people who've got these materials aware that the materials may have value and use, and make sure they can get them to those who can use them as efficiently, easily, cost effectively as possible. You might ask, with all this big picture dreaming of reuse and economies of scale, are there enough materials out there? The short answer is yes. We generate 13 megatons of municipal solid waste, such as hard rubbish, every year. As I said before, 24 kilos of furniture we throw out per person every year. When it comes to something like glass packaging, so your bottles, your beer bottles, your jars, we throw out 1.4 million tons of it a year. Uh, at the Reimaginarium, I don't advertise at all for materials, but every week I'm asked whether I can take items on, whether I can save them from ending up in landfill. If we can correctly manage the link between the materials that are out there and the people who can use them, I would be celebrating having a shortage of materials, because it would mean we'd be having an absolutely massive impact. So, looking at this material side of things, this start of the process, how do we centralize materials? How do we make sure materials can be gathered efficiently for makers? One option is to look at a physical premise, a warehouse. Yeah, it might be a centralized warehouse in perhaps in each major city. That warehouse might have the ability to receive and sort usable goods. And by being able to sort them and undertake basic quality and safety assessments of the goods, they can then prepare those goods to be redistributed to anyone who can use them. And that might be people who make products from them, that might be charities and op shops that can resell them, that might be for profit resellers who have particular niches of objects. If all the materials are ending up in this one central location, you've got the economies of scale necessary to prep, inspect, and sort those materials for those who can use them, with a process which might have just not been cost effective when those materials are coming in at small scales to individual op shops and individual locations. So why would we do this? As I said, economies of scale. If we can get enough materials flowing through the one space, we can process those materials in a way that's just not conceivable when they're currently coming into so many different individual little spots. Now, as our particular shop, we're already offered more materials than we can use. If we can pull them all together, we give makers a central location. So You're not spending days of the week searching for your cutlery that you're going to use for your necklaces. You're coming to one location and spending half an hour picking up enough stock to last you a week or a month or however long you need. And it also gives a viable option to individuals in our community who have goods they want to keep out of landfill. So I regularly talk to people who've been stashing things for months or years or decades because they've got sentimental attachment to the pieces, or they believe the pieces probably got value, and as such they haven't been willing to throw it out. But at the same time, they don't necessarily trust op shops to resell the items, and they don't know where to turn to ensure that the object is kept and used and seen for its potential value. So by having this central location, you give those people empowerment to do something with the materials they've got. Virtual model is also a highly plausible model. Now, let's say when an individual logs onto their council website and goes to try and book a hard rubbish booking, instead there's a second option on their screen which says, reuse me, would you like to reuse your goods? And instead of clicking on hard rubbish, you click on that link, and that link asks you a few basic details about what the item is that you've got to throw out. Might ask you the age of it, what the thing is, maybe some indication of what brand it is or what it's made out of and what defects it's got. And from that very basic, easy to provide information, instead of being given a link to organise hard rubbish, you might get given a list of 4 or 5 organisations in your area, all of whom would be willing to take that object. And once you select an organisation that you like, your details are provided to that organisation with all the details of the product that you're wanting to get rid of. And they can organise with you to either pick up or have that item dropped off at no cost. The reason behind this virtual model is that it's right in front of people. It's right there when they're thinking about what they're going to do to get rid of an item. And because it's now harder to do than booking a hard rubbish or organising a trip to the tip, there's no disincentive to doing it. It's capturing materials that people never realised had value. And all of that could well be wrapped up with a physical warehouse too. That pre-filtering could well be a pre-filtering that goes into selecting what materials can be dropped off at a physical warehouse. But even on its own, it's a viable way of capturing a lot of the materials that currently get thrown out because people just don't have an awareness of their potential value. Just to recap, reliable materials access is one of the number one focuses to us in the circular economy and the reuse economy, because if we have reliable materials access, then we can make things more efficiently. If we can make things more efficiently, then we can make them more cost effectively. And if our products are more cost effective, then they're more competitive. They're more competitive because we can price them compared to new products, or because we can produce a greater quantity of them, or because we can spend the extra money on upscaling and automating and improving the way that we do things. And all of that leads to more reuse and a bigger impact on waste reduction. So how do we make it happen? One local example of attempting to make this economies of scale work is Pianos Recycled. So they're based over in Keysborough. Traditionally they're piano restorers, piano tuners, but they saw the devastating numbers of pianos that were getting crushed and scrapped and sent to landfill in Australia because they are big, heavy things, and once they weren't worth tuning anymore, there wasn't really anything else that you could do with them. So to stop that happening, Pianos Recycled set up a warehouse back in 2017, and in that warehouse, they store and they dismantle beautiful 100-plus-year-old pianos. And because they've got the skills and the knowledge, they can dismantle those pianos efficiently. They can provide the timbers to furniture makers to make beautiful pieces of furniture. They can provide the ebony and the ivory from the keys to jewelers, and the metals can be saved and recycled. And those are things a jeweler could never take an entire piano to dismantle the ebony and the ivory, and a furniture maker, because of the weight of a piano, probably wouldn't even be able to drag one home, let alone know what the correct process was for dismantling it, to make sure they could do it safely and to make sure they could maximize the amount of quality materials they can get out of it. So pianos recycled with their experience is testing the economies of scale model for the reuse to make those materials available to different makers and individuals to use. On a much bigger scale, Retuner, which was set up in Sweden in 2015, works on an entire shopping mall principle. So they've got an entire mall full of shops that purely sell reused, repaired, repurposed goods. And they can do that because they've attached their business to a major landfill tip site. So while they've got this beautiful retail presence that draws people from all over the country and has drawn media from all over the world, in the basement they've got all the quality materials that are spotted in the tip as they're delivered. The tip get rerouted down to the basement of Retuner, and all the shopkeepers that work there are able to go down to that basement, pick out any materials that they can use for their shop, and use that as the starting point for the products that they sell in their retail spaces. So they're using both economies of scale on the retail side of things by bringing all these different shops together on one location, and they're using economies of scale on the resource side of things by taking in a large portion of the materials that are getting delivered to the tip next door and making use of them right there and then. What are we doing? So Reimaginarium, we're building relationships with both local and interstate organizations and community groups, because we want to set up something in this warehousing, distribution, repair and learning area, and we want to be able to do that here in Geelong. Well, the idea of having an extension of what we do now, having a retail space that connects to an education and learning and repair space that connects to this warehouse space that we feel is really critical to making reuse more efficient. We're dedicated to seeing this happen. We want to see this happen here in our local area, and we're seeking funding to make that possible. So we're currently seeking grant funding to combine those three elements together and to test that model here. We're also working on the virtual platform that we mentioned earlier to you. We've got our feelers and out at the moment. We've got a relationship with a really exciting organization who'll hopefully be able to bring us this platform that we think is a really big missing link in allowing people to realize the potential value of materials they've got, and identifying and capturing those materials before they end up in the back of a dump truck and in the landfill. So while we've got a long way to go, we're very actively wanting to see this reuse economy grow across the region, across the state, across the country, and we're working very hard to make that the case. For now, I think we need to celebrate the use and celebrate reuse, celebrate what we've got now. So I think it's really exciting that every reused item has a story to tell. Every piece that we sell and every piece that's made out of something old, it's unique. It's a one-off because it's been used. And these reused pieces don't exist if it wasn't for somebody having loved them before. So whether you buy something that's repaired, restored, repurposed, reimagined, or whether you repair or repurpose it yourself, you know the only reason that thing exists is because somebody loved it enough to keep it and to pass it on. And then you've got the love again from the person who's repaired it or repurposed it or made it into something that you can use. And I think that's a really nice element that you just don't get with a new product. Another really nice element or way to consider things is to consider yourself a custodian rather than an owner of a reused piece, because that piece has a story before you, and if you look after it, you're going to add to that story, and that story is going to continue on long after you've finished loving it. And that's everything for tonight for Found, designing for a reuse economy. If anyone's got any questions or would like to know any more, we'd love to chat tonight or at any time. Thanks for tuning in.